Radioactive Materials Safety Training for Uranium and Thorium Users. Presented by the University of Kentucky Office of Radiation Safety, Division of Environmental Health and Safety, EHS. The Radiation Safety Office within EHS provides oversight and support for the use of radioactive materials. This radiation safety presentation is specific to people who use uranium and thorium compounds such as uranyl acetate or thorium nitrate. It is not intended for people who plan to use other radioisotopes of uranium and thorium in quantities greater than grams to a few hundred grams. The university's radiation safety officer is Jason Johnson. You are encouraged to contact the Radiation Safety Office to discuss your concerns and with questions about any aspect of radiation safety. More information can be found on the website. Training topics: regulations, purchasing, radiation properties, chemical hazards, contamination control, waste disposal, and incidents. Radiation Safety Manual. Many of the university's rule for using radioactive materials is described in the Radiation Safety Manual. The use of uranium and thorium compounds does not require the same level of control required for most radioisotopes, as they do not automatically provide U and TH users with a copy of the manual. If you'd like to receive an electronic version of the Radiation Safety Manual, contact the Radiation Safety Office. Regulation of uranium and thorium compounds. Under Nuclear Regulatory Commission and MA regulations, uranium and thorium are defined to be source material. Typically, an institution must have a source material license to possess U and TH. However, the university's use of uranium is permitted under a federal regulation which establishes a general license for educational institutions to possess and use source material as long as the institutions possess no more than 15 pounds of source material at any one time for research, development, educational, commercial, or operational purposes. In 2014, this limit of 15 pounds decreased to 3.3 pounds. It will become especially important for the university to inventory and track the amount of uranium and thorium on campus. More about U and TH regulations. The Nuclear Regulatory Commission has determined that the hazard associated with the use of these U and TH compounds is small enough that the material can be sold without special controls on who may buy these compounds and without special requirements and precautions for using these materials. But there are some limited hazards associated with using these materials, and you should be aware of these hazards. It's very important to keep in mind that even though you can easily buy and use uranium and thorium compounds, the waste must be disposed of as radioactive waste. A later slide will discuss waste disposal. This training is provided to educate you about the simple precautions for the use of uranium and thorium. Purchasing and controlling uranium and thorium. Vendors are not permitted to sell most radioisotopes directly to researchers. The vendor must receive a copy of an institution's radioactive materials license before selling the material. But vendors can sell certain U and TH containing compounds such as uranyl acetate, uranyl nitrate, etc., to you directly. However, EHS does apply some limitations to your use of uranium. For instance, uranium waste must be disposed of as radioactive waste. You'll read more information about waste disposal later in this presentation. Limiting inventories of U and TH. Although there are no controls on acquiring U and TH compounds, there are specific requirements for disposing of the waste. For example, a vendor bottle of unused uranyl acetate would need to be disposed of as radioactive waste. Instead of purchasing your own U or TH compounds, you are encouraged to borrow material from other researchers on campus. We can help put you in contact with other researchers using these materials. If you do need to purchase U or TH, be sure to purchase the smallest amount that will serve your needs. Radiological characteristics of uranium and thorium compounds. This training presentation provides an overview of the radiological properties of uranium and thorium compounds and does not provide detailed information about radiation properties and its effects. Uranium and thorium properties. Natural uranium, depleted uranium, and thorium contain the following percentages of uranium and thorium isotopes. Both natural and depleted uranium and thorium possess very complex decay chains. See the decay scheme for U-238 and Th-232 on the next slide. Controlling external exposure. External exposure occurs when a source of radiation is placed near your body. For example, if you are sitting near a bottle of uranyl acetate, you will be exposed to those beta and gamma radiations that penetrate the sides of the glass bottle. The primary contributor to these more penetrating emissions are the two MeV beta particles emitted by protactinium-234, one of the decay products of U-238. Energetic betas produce bremsstrahlung X-rays in the wall of the glass bottle, which contribute to external radiation. The next slides will provide more detailed information about dose rates. What dose rates are possible? The surface dose rate on contact with a 100-gram glass jar of uranyl nitrate is typically 100 grams of unshielded uranyl acetate powder outside a bottle has a maximum dose rate of. Radiation dose is typically expressed in the units of either sieverts or rems. Sievert is the SI unit, rem is the non-metric unit, often used in the US. What dose rates are possible? Imagine that you are working with 25 grams and are 10 centimeters away from the powder. The maximum dose rate at this position is, at 1 meter from the powder, the dose rate would be. The dose rates associated with thorium compounds are not significantly different. The next slide will discuss the significance of dose rates. Are these dose rates hazardous? Background radiation from natural sources such as cosmic rays, radon, and naturally occurring radioactive materials in our environment and our bodies is always present. In the US, the average person receives an annual dose of approximately 3,000 from these natural sources. The next slide will summarize the typical exposure pathways to natural sources of radiation. Are these dose rates hazardous? How does working with this material compare to other radiation dose figures? Check out the table below. Limiting radiation exposure. If you only work with dilute solutions of uranium and thorium compounds or small gram quantities, there is no reason to be concerned about limiting your radiation exposure. The only concern is limiting exposure from the main stock of uranium or thorium in the bottles supplied by the vendor, which we'll call vendor bottles for the rest of the presentation. Although the dose rates from these bottles are not directly hazardous, it is good radiation protection practice to minimize radiation exposure whenever practicable. The effect of distance. It is easier to decrease dose rate by moving away even small distances further away from the vendor bottles. Store the vendor bottles of uranium and thorium compounds in locations that are not directly adjacent to frequently occupied areas. For instance, don't store the bottles next to your desk or on a shelf that is immediately adjacent to where you work. Since metal will provide some shielding, it might be useful to store the bottles in a closed metal cabinet. Why does the Geiger counter go crazy near the bottle? When a Geiger counter survey meter is placed near a vendor bottle of a uranium or thorium compound, the meter will indicate a count rate of thousands of counts per minute, depending on the amount of uranium or thorium in the bottle. This elevated count rate might concern you unless you understand the difference between the number of counts detected and the dose rate. Keep in mind the meter is responding to individual radiation emissions. It takes exposure to a large number of emissions to produce a measurable or significant dose rate. Conclusions about external radiation hazards. The doses you'll experience during routine use of uranium and thorium compounds will be very low, especially since most of your work will involve dilute solutions of uranium and thorium, and it won't be necessary to regularly or extensively handle vendor bottles of uranium and thorium. You should also be noted that the external radiation is not sufficiently penetrating to present a hazard for pregnant women. Chemical hazard. Uranium and thorium compounds exhibit the toxic properties of heavy metals and are more hazardous based on their chemical properties than their radiological properties. The normal precautions taken to prevent uptake of chemicals is sufficient to address both the chemical and radiological hazards. Exercise good contamination control. If you are working with the dry powdered form, take care to prevent inhalation and be sure to perform work in a chemical fume hood. Prevent ingestion by practicing good hygiene and wear disposable gloves, a lab coat, and safety glasses. Good contamination control practices. Wear protective clothing. For items that are easily contaminated, such as pipetteers, use equipment that is used exclusively for uranium and thorium work. Make sure that your work area is clearly labeled anytime radioactive materials are present. Label contaminated items and equipment. If you are working with a liquid solution, cover the work surface with absorbent bench paper. EHS wipe surveys. As a precaution and to ensure that you are practicing good contamination control, Radiation Safety conducts wipe surveys of surfaces in uranium and thorium using labs to verify that there is no removable contamination present. Radiation survey meter. On occasion, it may be necessary for you to use a Geiger-Müller survey meter. This will only be necessary if the radiation safety officer has determined that you are using uranium or thorium in quantities large enough to be detectable with a GM meter. In those cases, you will need to survey your waste materials before disposal to determine whether the waste should be disposed of as a radioactive waste or can be disposed of as a non-radioactive trash. If you do need to use the GM survey meter, the RSO will train you how to use the meter. Special issues. Thoriated welding rods. Thoriated welding rods, also known as thoriated tungsten electrodes, are tungsten rods containing 1 to 2% thorium, used primarily for welding and occasionally used for research and teaching purposes on campus. To ensure that the university does not exceed its thorium and uranium possession limit, you must notify EHS if you possess or use thoriated rods. The concentration of thorium in the rods is too low to present dose rates of any concern. The only radiological concern is the possibility of inhaling airborne particles if grinding of these rods occurs. Grinding operations to be performed in a fume hood. Uranium and thorium waste disposal. Vendor bottles of uranium and thorium compounds must be disposed of as radioactive waste. EHS will supply you with appropriate radioactive waste containers. Other uranium or thorium waste may or may not need to be handled as radioactive waste, depending on the amount of radioactivity present. EHS will review your procedures and determine the appropriate way to handle these wastes. The nitrate forms of uranium and thorium present special disposal problems because they are strong oxidizers. You are strongly encouraged not to use uranyl or thorium nitrate. Reporting incidents. If the following incidents occur, you must contact EHS at your earliest convenience. If you spill a solution of uranium or thorium on your skin or clothing, you spill uranium or thorium powder or solution on work surfaces, in the lab, or on the floor. The next slide tells you how to contact EHS. Who to contact. Call Radiation Safety at this number, or call campus police at this number. Do not hesitate to call no matter what time of day if the incident has occurred. In the event of skin contamination, notify EHS. Wash skin with mild soap and lukewarm water for 2 to 3 minutes. Do not use abrasives, organic solvents, and highly alkaline soaps to clean your skin. The simple step of gently washing your skin should be sufficient to remove all contamination. Conclusion. Consult with the radiation safety officer if you have concerns. Both the chemical and radiation hazards can easily be controlled with the same careful contamination control procedures used for work with other hazardous chemicals. Conclusion. This course is complete, but remember you are not approved to use radioactive material until your PI has approved you and your site-specific training is completed. If you have questions or concerns about any of the information provided in this presentation, contact the Radiation Safety Office at 859-323-6777 or jason.johnson@uky.edu.